So how can you do this problem in 30 seconds or less? The volume of a cube is 512 cubic centimeters. What's the length in centimeters of one edge of this cube? And the answer is A. How was I able to do this problem so fast? So I just know my extended exponential table, right? So I know that since the cube is 512 cubic centimeters, if you take the cubic root of the 512, we are going to get 8. Why that's the case? Well, because 512 is equal to 64 multiplied by 8, and then 64 in turn is equal to 8 times 8. So therefore, it's the cubic root of 512, which is equal to the cubic root of 8 times 8 times 8, which is equal to 8, and the answer is A. But lots of you guys do not know the extended exponential table. So how would you proceed with this problem? So the best way is to start working on prime factorization. So you do 512 and you start factoring it. So let's factor it together. So since that's an even number, it's definitely divisible by 2. So you divide by 2, you get 256. Now that's 256 is yet another divisible even number because of 6. So divide by 2, 128. And then you keep going, right? So 128 is 2 and 64. And then 64 is 2 and 32. And then 32 is 2 and 16. And then we'll continue here, right? So 2 and 16. So that 16 here is 2 and 8, right? And then the 8 is 2 and 4. And then the 4 is 2 and 2. Just do not be lazy. Just actually proceed with that. So now let's count how many 2s we have, right? So at the end of the day, 512 is just a bunch of 2s. So it's 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's very important. 9 2s. So if we are to write the cubic root of 512, that is equal to the cubic root of 9 2s. So 2 times 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 2. So we have a triplet of 2s, another triplet of 2s, another triplet of 2s. So therefore, since it's a cubic root, these would go out when you're expanding it, and you just left with one series, one triplet of 2s, which is 2 times 2 times 2, which is equal to 8. The answer is A. That's it.